Greetings and welcome to lecture 5.3, More Trinomials to Factor. In the last lecture, we started to factor trinomials with the first term. The coefficient in the first term was a 1, and therefore we only had to concentrate on the last term, what two numbers multiply to the last term but add to the middle term. Now, we're going to be a little bit more complex, and suppose the coefficient in front of the first term is not a 1. Well, then what we need to do is think about what two numbers multiply to the first term, what two numbers multiply to the third term, but when in some combination of those four numbers that they add to the middle term. Let me say that again. What two factors of the first term, what two factors of the second term, in some combination, add to the middle term. So that's a little bit more complex. But let's start off a little bit simple to where the first coefficient in the first term is a prime number, and the last term, its coefficient, is a prime number. Let's start off kind of gently, and then we'll move to larger numbers or more complex numbers. So the product of the first term is 2x squared. The product of the last term is minus 3, negative 3. So the possible factors, I'm just going to go ahead and do all possible factors. Well, 2 only breaks down into a 2 and a 1, and a 3 only breaks down into 3 and a 1. But it is negative. So my possible factors are a negative 3, 1, a positive 3, negative 1, and then flipping them. So now I have a negative 1, positive 3, positive 1, negative 3. Okay, the first term is always going to be what it was because I broke it down. It's a prime number, so 2x times x is 2x squared, and the reason why I chose 1 and 3 because they always multiplied to 3, and one of them had to be negative to get to the negative 3. So really, I only am concerned about that second term. So 2x times 1 is 2x. Negative 3 times x is negative 3x. Therefore, my second term, if I chose the possible factors, would be a negative x. I don't like how I'm explaining this. So using what we know, let's factor 6a squared plus 7a plus 2. Now there's a couple ways of doing it. One is I could write down every possibility of the combinations of products. Another way is a tree method, and I'm going to use the tree method for this problem. So I've broken down the first coefficient, 6, into its factors. So I can do 6 times 1, and I can do 3 times 2. Now I'm not worried about the reverse of 1 times 6 and 2 times 3 because all of my problem is positive addition, so I'm not too worried about reordering it and seeing what the possibilities are because they're going to repeat themselves in essence. The factor of 2 is 2 times 1. So I'm going to take the first 6 times 1, and I have two options for the factors of 2. I can multiply 2 times 1, or I can multiply 1 times 2. Now I said I wasn't worried about the reverse, but I am in this case because if I wrote this out, it would be 6x plus 1 times x plus 2, which is different than 6x plus 2 times x plus 1. And you'll see it in a minute how it builds itself. So the reversal is the second number of the set. So now I'm just going to multiply. 6 times 2 is going to be 12. 1 times 1 is 1. I add those two together, so my result is 13. Well, I'm looking for a 7. So that is not my combination. 6 times 1 is 6. 1 times 2 is 2. I add them together, I get an 8. That's not my path either. So let's try 3 times 2, 3 and 2. And again, my pathway is either going to be a 2 and a 1 or a 1 and a 2. So 3 times 2 is 6. 2 times 1 is 2. That gets me an 8. 3 times 1 is 3. 2 times 2 is 4. That is my solution path. So, here's how I write it out. My combination is going to be 3x and 2x. That would give me the 6, not a, x, a's, not x's. 3a and 2a, that gives me back to 6a squared. But I multiplied the 3 by a 3 by a 1 to get down to my 7 path. So that goes on the outside. The outsides are the multiplied by themselves, by each other. And then my internal, which would be the 2, is on the internal. That's one way of solving this problem, is to go down and write a tree for each one. And I just want to show you that if I would have reversed the two numbers, what would happen is the first leg would be that first leg, and then the second leg would be that second leg, just by reversing them. So I'm going to try another problem like this for you to see, and then I'm going to show you another way of doing it. Let's take the example 30x squared y minus 5xy squared minus 10y cubed. When I first look at a problem, I do want to see if there's a GCF that I can factor out. And in this problem, there is. I can factor out the GCF of 5y. If I factor out 5y, that leaves 5y times 6x squared minus. 5y comes out, so only an xy remains. 5y comes out, so that's a 2y squared. Now, I need to factor the coefficient of the first term and the coefficient of the second term. But I do know I'm going to end up with something that looks like some coefficient times x, a plus or a minus some coefficient and y. Some coefficient of x plus or minus some coefficient of y. How do I know that? Because I have an x squared and a y squared. The only way to get that is to have x's in the first term and y's in the second term. Now, that kind of eliminated some of my work. But now I have to figure out what are the factors of 6 and what are the factors of 2. My factors of 6 are going to be 6 times a 1 and a 1 times a 6, as well as a 2 times a 3 and a 3 times a 2. Order matters. My factors of 2, but it's really negative 2 what I'm looking for, negative 2, are 2 times negative 1, negative 2 times 1, and negative 1 times 2, and 1 times negative 2. That's a lot of work. If I did every single combination of these, it's going to be 6 and 1, 2 and negative 1, 6 and 1, negative 2 and 1, 6 and 1, negative 1 and 2, 6 and 1, 1 and negative 2. So it's all of these. In essence, it would be 16 variations. I don't want to go through 16 variations. So I want to be a little bit clever about this. Let's look at the 6 times 1 and the 1 times 6. And in any of these combinations, if I do a 6 times a 2, that gets me 12. 1 times a 1, that will either get me positive or negative 1. So I'm kind of looking around 11 or 13. Well, that's not the one that I'm looking for. I'm looking for a negative 1 in the middle. But 6 times 2 won't get me there. Also, a 6 times a 1 and a 2 times a 1 will either be a 4, negative positive, or an 8, negative positive. Because of that, I can immediately rule out that it's any combination with the 6 and 1. I just eliminated half my workload. Now, to maximum, I have 8 combinations. I want to eliminate as many as I can. So let's think about this. I have a 2 times a 3, and I have a 3 times a 2. And for each of these, I have a couple of pathways that I can go down. I can have the negative 1, or I have the negative on the 2, and it's just the reverse order. So let me do this. I'm going to take, and there's going to be 4 possibilities, so 2 times 3, and 3 times a 2. Now, why did I write that out? So I can see each pathway that I'm going to go down. The first is going to be the 2 times negative 1, and the other one is a negative 2 times 1. The second option is going to be 2 times negative 1 and a negative 2 times 1. The second set are going to be the options, but flipped in order. Negative 1 times 2 and negative 2 times 1. Oops, negative 1, positive 1 times negative 2. Sorry about that. And then I need to flip the order of these guys. Negative 1 times 2 and 1 times negative 2. Those are every single one of my combinations. Hopefully before I go through all of these, we'll find the one that works. So, if I go down, 2 times 2 is 4. 3 times negative 1 is negative 3. That gets me a positive 1. Really close. 3 times 2 times negative 2 is negative 4. 3 times 1 is positive 3. That gives me a negative 1. That's exactly what I'm looking for. But here's the trick. How do I bring this combination and write it up here as my factors? Here's how I do it. 5y times 2x. But the 2 multiplied with the negative 2, so those are my extremes. That goes on the outside. Those are my extremes. 3x multiplied by a 1, it is a positive 1. Those are my means. Those are inside, my means. That's how you would write it. So yes, I wrote it all out, thinking that I might need to go down each and every one of these paths, but it turned out I only had to go down 2. And then, bingo, I found my answer. And I don't want to forget my y's. So my y is hanging off there. So there is my final answer, 5y, and it can either be written as 3x minus 2y, 2x plus y, or it can be written with the 2x plus y in front. So either one of those will work.